So we're going to look at now, okay, on our page here, at the top of the page, you'll see that we're kind of using slopes to find missing vertices. So in example 2, it says, find the coordinates of the missing vertex in each parallelogram. So if you look here, we have something, we have some information, we have some points and some segments, okay? This is not a polygon, right? Because it's not closed off, right? For example, BD is not joined there. And in fact, we're not trying to make a polygon here. Well, I guess we are trying to make a polygon, but we want to make specifically a parallelogram, okay? So it says, oh no, that's funny, triangle ABCD, so I think they meant to put a parallelogram symbol there. Okay, we'll fix that. There it is. Okay, so parallelogram ABCD, find that if it has these vertices. Now, they were nice, and they plotted those points for us already. Okay, and we see have those 3 points, and we want to come with point C. Now, hopefully you guys all kind of have a general idea about where point C is going to be. Yeah, it's going to be like somewhere like right up in here, right? It's got to be somewhere in this area to make a parallelogram, right? It can't be like up in here. That would not make a parallelogram. It can't be like down in here. It won't make a parallelogram. None of these like points are going to make parallelograms, but somewhere in here will. Okay? So, to make that parallelogram, what are we going to do? Well, what did we do yesterday to show something was a parallelogram? We found the slopes, right? And we needed those slopes for opposite sides to be what? Equal, and therefore parallel. Okay? So, we got to somehow move the slopes there. Hello? Not fine. Yes. Absolutely. No problem. That way they want you to be center to take your part. Hooray. You're not in trouble, Derek. All right. So we got to figure out where we're going to put our points. Okay? So if you look here, let's find the slope of AB. Okay? The slope of AB, we're going to go down 1, 2, 3, 4, 5, and right 1, 2, 3. So we went down 5, and then right 3. Okay? So how can we move then from point D, how can we move to get our point C? We're going to go up, 1, 2, 3, 4, 5, and then left how much, Krishna?
No, you only go 4.
Only go 4?
3.
Well, so, we're going to go left 3. So 1, 2, 3, 4, 5, left 1, 2, 3, and put our point right there. Okay, there's where point C has to be. Why is that? Well, because the slope from B to A was a slope of down 5, right 3, so we need to put point C so that its slope from C to D is going to be down 1, 2, 3, 4, 5, and right 1, 2, 3. See? Down 5, right 3 gets us to point D. So that is the location of point C. Now, did I have to use BA's slope? No. What other slope could I have used there? Could have also used AD. And let's just check it to make sure it's right. AD slope is up 1, right 1, 2, 3, 4. So from B, up 1, right 1, 2, 3, 4. There it is, same exact point. So either slope is fine to use. Okay? That was it. We're done. We made the parallelogram. So C has to have coordinates. What are the coordinates for point C? 2, 4. So that's the coordinates for C. Yes, Zaria, question.
So did you get like 5, 3 from like going down and over?
Yep. I just counted the slope. I did the rise of -5 and the run of +3. Okay? And so then I had to do the same thing here, except kind of backwards because of where point D was, But that's the basic idea. All right? So any other questions on that? All right, so let's try letter B here, this next one. So we want to come up with another parallelogram, PQRS, with vertices P, -3, 0, Q, -2, 4, and R, 2, 2. So, first thing we got to be careful of here is make sure we plot these points accurately. So P, -3, 0. That means from the origin I'm going to go left 3 and not up or down at all. So there's my point P right there. Okay? And then Q has coordinates of -2, thank you, it's -2, 4. And so Q, -2, 4, so -2 to the left, and then up 4, so there's Q right there. And then R has coordinates 2, 2. All right, so it looks like that's going to be our shape right there, right? We can connect those two. And so again, hopefully we can kind of picture here, where does it look like, you know, S will end up, that fourth point? Where's it going to end up?
Like 2, 1.
Yeah, maybe like 2, maybe like -2 or 1, -2, somewhere down in here, right? Right down in here. Right down in this area. So again, how can we figure out where it's going to go? Yep, let's just count the slopes. So you can either use, I'm going to use Q to R. I'm going to use Q to R slope. So Q, I'm going to go down 1, 2, and right 1, 2, 3, 4. So down 2, and then right 4. Okay, so from P, we'll do the same thing. Down 1, 2, right 1, 2, 3, 4, and then boom. Okay, there's where S has to be. What coordinate's that? Okay, good question. So what is this coordinate, folks? 1, -2. So there's our answer, 1, -2. Okay? Pretty straightforward. All right. Questions on any of that? Just using our slopes. All right. Let's turn the page here. Excuse me. All right. Let's try one more of these, and then I'll get you guys started on your assignment, okay? Because that's pretty much all we're going to be doing today, just practicing that. Just make sure we're good with it, okay? So, parallelogram JKLM. Okay, let's plot these points. J has coordinates -3, -2. Okay, K has coordinates 0, 1. And M has coordinates 1, -1, 2, 3. So there's JM and KM. Okay, and I may have made... Yeah, I may be not. I don't know if I connected those right.
Yeah.
J, K, L. Yeah, L's got to be over here. Whoops, this should not be in. That's the diagonal. That one should not be in there. This one should be. Okay. Yeah, sorry. This is a diagonal. And again, how did I know that those were the right order? Because it's going to go J, K, L's got to be over here, and then to M. So J, K, L's going to be over here, and then M. So yeah.
Go down 3, I'm not saying it right, but I counted.
So which slope? So Zari, which slope did you count here? From J to K or from J to M or?
K to J.
K to J. Okay, so from K to J, you went which direction?
Down 3.
Down 1, 2, 3.
And then left 3.
Left 1, 2, 3. Right. So we went. So to get from K to J, we had to go down. I know I'm out of. Down 3 and then left 3. Okay. So then our point here, wherever L is, we're going to have to go down 3 and left 3 from that.
So instead you go up.
Yeah, instead we'll just go right 3, 1, 2, 3, and up 1, 2, 3. And there's where L's got to be. Question?
Yeah, I did from J to K, and you get 3 over 3.
Yep.
But if you're supposed to do the opposite and you start at point M, then you're going to go off the graph.
No, okay, so I see what you're saying. So Zaria had to go the opposite direction because of the way she counted. She counted from K to J, and so going down 3, left 3. And because L, she would have to start counting from L, she didn't know where L was, so she went backwards instead and went up 3, right 3. Since you, go ahead.
The slope you get, you don't change.
So in your case, because you counted from J to K, okay, that means you're going to start at M, just like the J.
Is that what we did in the last problem?
The last one, so the last one, we went from Q to R, right? And then if we start at P, that will then take us to S, right? It kind of matches there, from Q to R,
Yeah.
P to S.
So you went down -2.
Yep,
And then went across
Right.
+4. So,
or +4, yes, right.
So you would be doing the same thing for point.
From P to S, right? Because Q corresponds kind of like to P. But whereas here, because of the way that Zaria chose to counter slope, and again, you guys can counter slopes any way you want, it's still the right slope, but since she saw that went this way, down 3, left 3, she's going to have to go backwards because of where she was starting at M and going, up and right to the point L there.
And can't you use the parallelogram on the J that as like a directional where it says missing.
Yeah, and that's why I made my mistake with, yeah, I made my mistake. So let me clarify that one right here. Okay, so here we can see that we have points E, F, and G, and we won't do this full one. Actually, I mean, might as well. It's very easy. So let's just do it. So E is -2, -2, 2. There's E. Shh, Kyle, Derek, listen up, please. We're almost done. F has coordinates 4, 1. Okay, and then G has coordinates 3, -2. Okay, and I want to find point D, vertex D here. Okay, so again, it goes D, E, F, G. So I can connect E to F because I know that's going to be a side. I can connect F to G, and then D is going to be somewhere over here.
I thought it was down one, I went from E to S, so I did down one.
Right, so down one and then right that much. That means you have to go up one and then left that much. Exactly right, sorry, exactly right. Okay, so again, in this case, let's just pick a side. Okay, so, I don't know, you know, Jaden,
Yeah.
pick a side here. Which side do you want to pick? Just pick one. I mean, like, it's literally just pick one. EF, okay, so let's find that slope here. So we're going to go down 1, and then right 1, 2, 3, 4, 5, 6. So right 6. Okay, and so then our point over here, wherever D is going to go down 1, right 6. But again, we don't really know where D is, so instead of going down 1, right 6, up 1, left 6. That's right. So up 1, 1, 2, 3, 4, 5, 6.
Oh, that makes sense.
So there it is. Okay, this almost looks like it is a rectangle, but it's not quite. If you look at our slopes here, it goes up 3, right 1, so the slope there is 3 over 1. But the slope here is down 1, right 1, 2, 3, 4, 5, 6. Down 1 over 6.
Yeah, so it's a...
It's not quite the same thing.
It's like one of them, like, weird parallelograms, right?
It's a parallelogram. Just a parallelogram. Okay, so that's that. So let me give you guys your assignment. You get started on that.
You should not give us homework on our, like, the missile day.
What do you mean? You have extra time to do your homework. So I
I
should
know,
do
but
more
You
homework.
shouldn't give us homework. You should let us have fun.
All right, so here's your assignment. Sorry? It's basically the same stuff from yesterday, yeah. So page, I'll go ahead and end.
Mr. Woodmark, I put over there.